Hi there. Today, I'm going to demonstrate how to use Aurora's Array Tool functionality for powerful commercial design. The Array Tool can be used for racked systems on flat roofs, any ground mount, and carport systems as well. I'm going to start with a regular commercial flat roof in Aurora. I've completed the 3D model, and I'm in the Design Layout mode. To initiate the Array Tool command, I click on Add Components, then Array. The keyboard shortcut for this is an A followed by an A. Here, I can select my module, add any microinverters or DC optimizers, set the number of rows and columns for a single rack, and choose a landscape or a portrait orientation. Then I can set the tilt of the rack, the height off the roof or ground, as well as the module to module spacing in both the X and Y directions. These spacings would typically be around ½ an inch, depending on the racking hardware that's used. If I want Aurora to automatically place string lines across my rows, I'll check the box that says String Rows. Opening up the advanced options, I see another set of inputs which are used for building arrays of arrays. Here, I can set the number of rows and columns of full arrays, as well as the array-to-array spacing in both the X and Y directions. This could be 4 feet in the X direction and 8 feet in the Y direction, for example, depending on shading and spacing requirements. Notice at the bottom that the total number of modules in the DC system size will update accordingly based on the inputs. After clicking OK, I can place my arrays in the model space. Note that they can be placed on a building and they will snap to the direction of the azimuth arrow automatically, or they can be placed directly on the ground. The Array tool does not require a building to be drawn. I can simply move directly into design mode and place arrays directly on the map. I'm going to place my arrays on the building. It's important to note that each block can move independently, and you can grab multiple blocks by holding the Shift key or using the box select command. Then I can perform normal Aurora functions like move, copy, paste, and delete. It's also possible to drag and stretch additional rows and columns of each block in all 4 directions. Note that it may affect the original string lines, so sometimes it's best to rerun the command again to resize them. Going into 3D visualization, the 3D renderings of the arrays is available. Powerful adjustments can also be made here by clicking on an array and bringing up its properties. Note that holding down Shift and grabbing multiple arrays allows for group adjustment of the properties. I can further adjust the tilt, rotation, and height of the arrays directly from here if necessary. Changing the positioning field from relative to absolute We'll set the rotation value to an absolute scale, with 0 being due north and 180 being due south. As always, here in 3D visualization, I can simulate the shadows for every hour of the year using the controls in the bottom right corner. This can be used to ensure proper array spacing and to avoid inter-array shading. Finally, I can move into simulations to run the performance analysis. Note that without connecting inverters, only the PV watts engine is available, and Aurora will use a default inverter efficiency value. This is a quick way to get a general idea of the system's annual performance. If I want to run the more robust Aurora simulation engine, I can go back into the layout and add inverters. I can click on Add Component and then choose Inverter and select the desired inverter for my system. Placing it in the model space, I can now use the Connect feature to quickly connect my existing string lines to my inverter. As always, if I'd like, I can manually edit and customize my strings by using the string function. Remember that the colors indicate acceptable string voltage based on my module and inverter selection. Red is out of range, green is acceptable, and yellow indicates maximum string length. Also, don't forget that Aurora is constantly performing dozens of validation checks to ensure that the design is code compliant and meeting design best practices. The validation report at the bottom shows the checks being run and if any are failing. And lastly, remember that using the box select or typing Control-A to grab everything will allow you to perform normal Aurora functions like move, copy, paste, and delete. I can now go back into simulations to generate the Aurora Sim performance estimate, which automatically includes the hourly shading engine from the 3D model. This concludes our video for today. Thanks for watching. Remember to email support@aurorasolar.com with any questions. Have a great day.